we are starting a new unit, which does still put us in the realm of linear functions. We're going to talk about some kind of special types in Unit 4, including direct variation. That's today. We'll talk about something called point-slope form, which is kind of like the cousin of slope-intercept form. It's another way to write a linear function. And then we end the unit talking about parallel and perpendicular lines. Both of those are POs. Of course, in the table of contents, you can follow along there. So we will have a test before we go for Christmas break.
What?
Brad. That shouldn't come as a surprise. I said that twice already. So we will have a test before we leave for Christmas break. And so we will, luckily, these go pretty quickly. This is a one-pager here. And basically, all we're going to talk about is it's determining whether an equation has direct variation. Okay? And like we discussed, here's my little avatar. Here's me. Okay? Like we discussed in CO25, a relation with slope is a linear function. Right? If something's a linear function, it means it has a slope. If something has slope, it means it's a linear function. Kyle, what are you coloring on, drawing on? Are those cards? Put them away, please. Or I just got myself a new set of cards. James, you have cards out too? Put them away. Or I got myself a new set of cards. And so there's a special type of linear function called direct variation. And direct variation exists when a linear function, here's the key, passes through the origin. Passes through the origin. When a linear function passes through the origin. What is the origin? Emerson? 0, 0. It's that center point where the x-axis and the y-axis intersect. That is called the origin, is the order pair 0, 0. And the reason why that's called direct variation is, there's a direct relationship between x and y. An example of something that is direct variation would be something like y equals 2x. And I'll put the plus 0 here, just because it is part of slope-intercept form. But there's a direct relationship between x and y, right? Whatever x is, you double it, and that gives you y. That's it, right? You're not adding or subtracting anything after that. Okay, it's a one-step thing. So to determine whether or not direct variation exists, basically, you need to figure out what b is, what the y-intercept is. Right? In slope-intercept form, figure out what b is. If b equals 0, then it is direct variation. So we're still in the realm of writing equations of slope-intercept form and linear functions, things like that. But now we are looking specifically at a certain type. What happens when b equals 0? It means it is direct variation. Okay, so it says write the relation in y equals mx plus b to determine if the relation is a direct variation. If it is, find the constant of variation. Constant of variation. This is just a super fancy way to write slope. Right? So if it is direct variation, we are then looking for what's called the constant of the variation, which again is a really fancy way to write slope. Okay? So the first one, just by looking at it, being a graph there, is that direct variation?
Yeah.
And how do you know?
Because it hits 0, 0.
It passes through the origin. You can see it there, right? We don't have to write the equation to see that this is direct variation because it passes through the origin. But the directions do say to write it in slope-intercept form, so what is that equation in slope-intercept form? Henry?
1/3.
Is the slope, right?
Yep.
So y equals 1/3 x. You can put the plus 0 if you want to, but you don't have to because adding 0 doesn't change the value. So, two things. Yes, direct variation. Yes, dv. I'm going to abbreviate. Yes, direct variation. And then what is that constant of variation?
The slope.
Also called the slope, which is what? 1 third. Okay? So yes to direct variation, the constant of variation, which is just a really fancy way to name slope, is 1 third. Which means that whatever x is, you take 1 third of that, you get y. You don't have to add anything or subtract anything. How are we doing so far?
Fine.
Alright,
Sure.
next one. In slope-intercept form for you, raise your hand if you think yes, direct variation. No one? Not even to be silly?
No.
Oh, Lakely! And think, oh man, and Peyton. No, why is it not direct variation? Grace. Right, the b is not 0, okay? Y equals 4x plus 2. This means it passes through the point 0, 2, not 0, 0. Therefore, it is not direct variation. Not dv. And since it's not direct variation, there's no constant of variation. There is slope, but it's not called constant of variation in this case because direct variation does not exist. So we don't have to do that step either. Lucas. Henry.
So basically, constant of variation is slope, but slope is not constant of variation sometimes.
Constant of variation is what we call slope when direct variation exists.
Got
If
it.
there's no direct variation, there's no constant of the variation. There's still slope, but it's just called slope. Okay?
It's like a square.
The next one, XY table. Welcome back to PO24. I'm going to scoot this down a little bit here. Welcome back to PO24. A few of you need to retake this on your test, which is why I put some on here. So just for review, folks, just for review, how do we write this equation in slope-intercept form when you're given a function table like this? Here's your hint. You need to find the slope, and you need to find the b. How do we do those? Lucas.
Well, you have, first you would look at each of the things and you add them up. Like, that one's plus 6,
Okay.
plus 3,
What are you looking at plus 6? Oh, you're
The
like
x.
here?
plus 6,
Okay.
and then on the plus 3,
Plus 3.
and then plus 9.
Plus 9. Okay. And go to the other side here. This would be plus 8. And plus 4. And plus 12. Right?
Which are all
Okay.
4 over 3.
Which all simplify to be 4 over 3. Right? 8 over 6 is 4 over 3. 4 over 3 is obviously 4 over 3. 12 over 9 is 4 over 3. So what's the slope of this relation? 4 over 3.
And then you could go back from the first one to get 0, 0.
Okay, and so I want to use the equation method though. Okay, what order pair do you want to use? Because this is what I do in PO24. It's good to practice. What order pair do you want to use to plug into slope-intercept form to solve for b? And quite frankly, correcting the test, if you need to retake PO24, most of the time is because you got the wrong y-intercept. You got the right slope, but then you plugged it in the equation wrong. So again, good review here. Which order pair do you want to use?
The 3.
The 3, 4, okay, right here. Does it matter which order pair you pick?
No.
Absolutely not. So, y equals mx plus b is our equation. We're plugging in 4 for y. Our slope, we got 4 thirds. Our x value is 3, and we're solving for b. Okay? Solving for b. First step, do the multiplication. What is 4 thirds of 3?
12. Wait, no. 4.
4, right? Couple ways to think about this. First of all, what's 1 third of 3? Well, that's 1. We want 4 of those, so that's 4. Another way, 3 divided by 3 is 1, times 4 gives us 4. Or, old school method here, 4 thirds times 3 over 1 gives us 12 over 3.
I'm old school.
And what's 12 divided by 3?
4.
4. So either way, we get 4 equals 4 plus b. What do we now get b by itself?
0. You cancel out that.
Subtract 4 from both sides, and they end up canceling out from both sides. 0 equals b. So is this direct variation?
Yes.
Yes.
Yes. The equation is y equals 4 thirds x. If you want to put the plus 0, you can. You don't have to. So yes to direct variation. And what is the constant of variation? 4 over 3. It's the slope that exists when you have a direct variation. Okay? Do you get what you're supposed to be doing?
Yeah.
Are you picking up what I'm laying down? Okay.
Is it the constant just like the slope?
The constant variation is the slope. When direct variation exists, the constant is the slope. The next one here, it's not in the slope-intercept form, it's in standard form. So to put it in slope-intercept form, we're going to get y by itself. This is a good review of PO22. Okay? So we're going to start by subtracting 2x from both sides, which gives us 7y equals negative 2x plus 0. Right? 0 minus 2x, that x term comes first, negative 2x. Remember, when you move something from one side of the equation to the other, the sign has to change. This was the biggest mistake in PO22. Okay, that's not changing the sign of something when you move it from one side of the equation to the other. It's going to be a negative 2x on the right side, because you have to subtract it to move it there. Okay? Now, divide everything by 7. Negative 2 divided by 7 doesn't work out evenly, but we don't care, because that's slope anyway, fractions. So negative 2/7 x, 0 divided by 7 is 0. Is this direct variation?
Yay.
Yes, because that y-intercept is 0. dv, yes. What is the COV?
Negative 2 over 7.
Negative 2/7. It is the slope when, I can write with the back side of this? That's kind of cool. Just learned that today. It is the slope. Right, it makes sense. I've never tried it before. It is the slope when direct variation exists. Okay? So, the next 4 are all more examples of things that we have done previously. The 2 function tables, good practice for PO24, and then the graphs are what they are. Down at the bottom, though, things get a little bit interesting. You have some equations that are in a little bit different forms. You have like variables on both sides here, things like that. The goal, again, is to write it in slope-intercept form, which means get y by itself. They're just a little more steps than what we've done previously. So which one would you like to do together? I think I know which one. Should we do the first one? Sure. Okay. So the first one, remember, our goal is to get y by itself. We want y on the left side of the equation, x on the right side of the equation, okay? Which is already happening, right? Y is already on the left, x is already on the right. So do we have to do anything with the x term?
No.
No. What do we have to move?
1.
The positive 1, right? So we're going to subtract 1 from both sides. This case, we can combine it with the 4, because they're both constants. So now we get 3y equals 6x plus 3. Because positive 4 minus 1 is a positive 3. Now this probably looks very similar to other equations that you've seen. What's our last step, Kyle?
Oh wait.
Asher, do you know? Divide by 3. Well done, Asher. Yeah. You get y by itself, divide everything by 3. And so we get y equals 6 divided by 3 is 2x. And then 3 divided by 3 is positive 1. Is this direct variation?
No.
No, it is not, because b is not 0. So no dv. Okay? So it's a little more steps than we've had in the past to put them into slope-intercept form, but that's what you are wanting to do. Yeah?
You don't simplify the slope, 0.
You should simplify the slopes, yes. Okay. Now, that next one, this is a little math hack that some people miss. It's got 4 times x plus 1. When you see parentheses, which means you're going to have to do what? Distribute, okay. Also, I see my x term on the left side and my y term on the right side. I want it the other way around. I want my y term on the left, my x term on the right. Does that mean that I have to move my 4x term over and move my y term over?
Yeah.
No. What can I do to avoid moving them around like that? Fiona?
You just like do it the opposite.
Yeah, if 4 times x plus 1 equals 2y minus 4, that means that 2y minus 4 equals 4 times x plus 1. Ta-da!
What's this
Now my
called?
y is on the left, my x is on the right. I still gotta do other stuff, okay? But I didn't have to use opposite operations to move them over, right? Because just like, you know, you learned in 3rd grade, or it's just 2nd grade, 2 plus 3 is 5. That's the same thing as 5 equals 2 plus 3. Okay? We can use that here. Henry, you keep trying to interrupt me. Raise your hand. Right? We can use that here to avoid having to move stuff from one side to the other. We can just flip it. Okay? And this is the reflexive property, is what we just did here. Actually, the symmetric property. Sorry. Symmetric property. You learn that next year in geometry. But now you got to do stuff to get y by itself, but at least you don't have to worry about moving terms. Okay? Hi, Eddie. All right, questions, comments, concerns, complaints, compliments, congratulations, criticisms on this. James?
The 11x and 10y.
Yeah.
I don't understand.
Well, we can start by moving, just flip-flopping these. So our y is on the left, our x is on the right. Okay, that's kind of where we want them to end up anyway. And this is kind of very similar to the one we had in the examples, especially if I put a plus 0 here. Now this looks very similar to that 7y equals 8x1 or negative 2x or whatever it was. Okay, so look at what we did up there. See if you can apply to this one here.
I got it.
Okay? All right, Henry.
Is the bottom one, is that a question or?
No, the bottom one is not a question. This is the who cares? Why do we have direct variation to begin with? Most real life situations are direct variations. Saving money on a daily basis, on day 0 you start with $0. If you're going on a family trip and tracking your miles, how many miles you go per day perhaps, on day 0 you've driven 0 miles, right? Whenever you start at 0, that is a direct variation situation, which is oftentimes what is happening. Okay, oftentimes what is happening. All right, your homework is to finish the page, identify when direct variation exists, and then what is the constant of variation as well. We good?
Yeah.
Play the number game tomorrow?
Maybe.
Let's do this.
Come
All
on.
right, that's how you math.
Don't forget to like and subscribe.